Hey there, I just wanted to share an update of some work that I've been doing for some pieces of art, and specifically I'm going to try to bring some stuff to the Applied Algebraic Geometry Conference in July. And I've done some fun work in the past with my 3D printed Barth sextics. So these are 2 pieces out of 20 and they snap together, and then I can snap them back together, and if you put 20 of them together you get this cool star thing. And I feel like people have seen the Barth sextic. It's really cool. New people to it are like, wow, that's amazing, but I'd like more pieces in my repertoire, and I have this little friend right here. This is my friend Nordstrand's weird surface. This is a 2-color version. That's not what I'm going for right now. This one's hot glued together, and it's 9 pieces. There are 5 different kinds of pieces as opposed to the 1 different kind of piece, more or less. I want to be able to 3D print this and snap it together, and so I've been working to put that together. And I have here on my screen a version of it. So this is OpenSCAD, and I can poke around in it. I've got plugs and I've got sockets, and I absolutely cannot, I cannot use this. So if I just plot one of the pieces at a time, say, like this one looks pretty good, and this one renders pretty decently, but if I say take, I think piece number 3 fails. No, let's take piece number 2. So piece number 2 here, pretty simple. We're just going to cut basically a cylinder out of it and then embed another cylinder around it as a socket to plug stuff in. And I'll ask it to render, and it's going to fail. I get this all the time. This is a CGAL error. CGAL is the Computational Geometry Algorithms Library. This very unhelpful error that doesn't really tell me what the symptom is. Just get essentially it's not a crash, but nothing useful can happen with this. So I'm screwing around in Blender to produce different models. And this is one that I produced in Blender by essentially taking a copy of the object and subtracting it from itself with some scaling. And for n equals 0, it works. So this friend right here, if I run this through, I don't think we're going to wait for this to render right now, but I believe it will successfully render. And most of them don't. So then I was like, okay, let's try some other ways of algorithmically producing these things. And this brought me to the world of Rhino. So I've got some Grasshopper code right here. I've been working on this with my students for quite some time. And more or less it's in 2 blocks. The upper block up here more or less processes curves embedded on surfaces. That's not really what I'm working on right now. This bottom part right here does some stuff with the surface itself. And what I've been trying to work toward is a copy of a surface subtracted from itself. So doing in Blender, but more algorithmically. So if I switch over to Rhino right here, we can see kind of what I'm going for. So I've got the bottom piece, just a piece of an algebraic surface that's non-compact. It goes off to infinity. It's been cut by a sphere. We're not seeing the sphere right now. And I have 2 copies of this thing, and I'm trying to subtract one from the other. And the subtraction fails because it doesn't think that the 2 meshes are watertight. I really wish that it showed as watertight, but it doesn't. And I feel like there's not a lot that I can. Well, I don't know. So what I need to do is I need to take the code that has the surface piece and then the cap. So what I've done is I take the part that intersects with the sphere. So I've got that here in the sphere curve part right here. That reads in from some Python code, and I have some other Python code that dumps the points on the intersection with the sphere to a file, and then we read those in. I've got those points right here, and what I'm doing is I'm forming a polyline about that. It's closed because it's a closed circle. I'm doing this manually right now. I could algorithmically compute this Boolean value right here, and then I am forming a triangulation on that closed polyline, which is the cap on the end of it. And so if I enable the preview right here, and let's see here. So that's this piece that goes around the border. That's the polyline. And then there's a triangulation that lives across the center right here, which hypothetically should make a closed object because it is using the same coordinates. Grasshopper / Rhino just doesn't know that it's using the same coordinates, that these points are the same for the STL file that it read in, and for this curve right here. And so I could play some stupid game to like find the corresponding points from the STL and then merge them together, and I just think that that's going to be a giant pain. So what I really need to do is, instead of bringing in the stuff as an STL file, so here's my read STL file block right here, instead of reading this STL in and then working with it, I need to bring in all of the vertices at once and use the common vertex set, both for the face patch and for the curves that are read from this block of code, because then they'll actually know that they're the same point, and I don't have to do like vertex collapsing nonsense, which just seems really silly because like I have them as the same objects. I just don't know how to make it happen right yet, but that's my next task, I think. Thanks.